Great. Hello, everyone. My name is Ethan. I'm a mentor with Program Equity. I volunteer as a mentor. I've been participating in this for the last 4 cohorts. Today, Kalam from HashiCorp will be giving us a presentation. I do want to thank Kalam and HashiCorp for just taking the time to do all of this. And I want to say thank you very much for everyone waiting. I know I'm running late today.
Ethan, we also have Johnny from HashiCorp.
Johnny, I appreciate it. Thank you so much for joining today.
You're welcome.
All right, so let's see here. All right, so let me go ahead and share my screen here. All right, so just kind of give you a walkthrough of the app. I am not the most articulate on this. I kind of focus on the workflow and action sections, but we can go ahead and provide a breakdown of the app just for everybody's general knowledge. All right, so Amplify is an app that you can use to set up campaigns to help provide the ability for people to amplify their voice. The app itself will allow you to write a letter and send it to a local, state, or federal representative. Is the app running currently? No, we do these projects through each HackPod, which allows people to just build the app. We don't provide it to anyone. It is an open source project, so people can download it and use it at their will. But we don't have a active going app that is sending out campaign letters or anything like that. It's more of a learning project. Throughout the app, we have our current structure, and we separate it into 3 distinct groups. We have a front end, we have a back end, and then we have an architecture part. The front and back ends are going to be a mix of JavaScript. Christian, do you know what other languages we are using to build this app with?
Vue.
Vue. Thank you very much.
Yeah.
And throughout the cohort, we will build it, and by the end of it, it will be a fully functioning application that allows you to look up any representative within your zip code. You can type a letter within the app, and the app itself will go through the process of printing it physically in the real world and sending it to a representative of your choice. Today, we're going to be working with Kalam. He's going to be providing a overview of just how important HashiCorp Vault Secrets are, the practicality of it, and how it's used in a day-to-day, how people are using it in enterprises and organizations, the relevance of it, and he'll go into some topics of like the architecture of how it works on like a bigger picture, and he'll provide just an overview of exactly how HashiCorp can benefit your career if you are interested in learning about the technology. With that said, I would like to introduce Kalam. I do appreciate you doing this. And if you have any questions, feel free to post them in the chat. We can answer them, or if you want to, we can answer them as they come. Also, if you have any further questions, you can wait till the end as well. It's we'll answer them as they come.
Cool. All right. Thanks, Ethan. Thanks for putting this together. You know, it's great effort from you and your team to put this together. So all right. So we'll start with little quick introductions. Myself and Johnny, I'll go first, and I'll let John introduce later. Hey everyone, I'm excited to be here today with you all discussing HashiCorp Vault. My name is Kalam Abdul, working as a senior resident solutions architect at HashiCorp. I've been with the HashiCorp for a little over a year. I work with one of our top customer in financial service industry, addressing their security challenges with running workloads across multi-cloud and on-prem. I provide the guidance in general specific to the HashiCorp suite of products. And yeah, I'm excited to be here. John, you want to go next?
Yeah, hi, I'm Joni Delaporte. I have I've been at HashiCorp for a short while, but I'm also from Red Hat prior to that, and I have about 15 years of experience in system administration and building and supporting large-scale enterprise infrastructure. So I'm excited to teach you guys what we know about Vault today.
Awesome, thank you. All right, so this is the agenda for today. We'll talk as Ethan did mention that we want to make sure when applications are deployed, they are deployed with having in place all the best practices, making sure the secrets are secure and applications can read all the sensitive data with all the security measures in place, right? So today the agenda will cover over why HashiCorp Vault, go over Vault architecture, and we'll discuss some of the internal components related to the Vault, specific to authentication, secret engines, and go over some of the best practices. All right, so with that, let's dive into this. This is interesting. A lot of people in IT, they know our products first, then the HashiCorp name, right? So they know, well, Terraform, Vault, but they don't realize they all come from the HashiCorp. So that's interesting. So I would like to take a second here to introduce what is HashiCorp. HashiCorp is a software company that provides infrastructure and security automation solutions. We offer a suite of tools designed to help organizations manage their infrastructure more efficiently, particularly in the cloud and on-prem and multi-cloud. Some of our popular products include Packer, Vagrant, Terraform, Vault, and the Console. Before we deep dive into HashiCorp Vault, let's understand why we need a secrets management solution like HashiCorp Vault. So in this slide, HashiCorp has surveyed our enterprise customers running in cloud. We ask our customers, what is the top concern of running workloads in the cloud? And the answer we got was leaked credentials is considered their top one risk as compared to data theft and phishing social engineering attacks. And the reason for that is this is the survey from the Verizon that 9 out of 10 web application breaches that happens across the enterprises, it's because of stolen credentials. And out of those, 3 out of 4 are some sort of a human element, and there is 4 times increase in the security breaches in the last 2 years. Looking at all these challenges that our enterprise customers are running, how HashiCorp Vault can support our enterprise customers' risk management and how to increase operational efficiency efforts for security, we have come up with this approach called security lifecycle management. Let's take one step back and understand when we set up our applications to be secure at start is just a step one, right? We make sure it's deployed with all the best practices, with all the bells and whistles, like making sure there are application gateways in front of the application. This is all good, but there are other challenges you will face on day 2 and day 3 of keeping applications secure. right? How are we going to reduce the risk profile over the time? So we call this approach to solving this challenge, as I said before, is a security lifecycle management, SLM, which is core offering of HashiCorp's infrastructure cloud. SLM enables your platform and security teams have systems in place so that they can inspect and protect all the sensitive elements of your environment. And this sensitive data could be secrets, certificates, API keys, or customer data. Once we have those systems in place to protect and inspect, then you can enable your application teams to securely access this sensitive data based on identity, right? And HashiCorp provides a portfolio of products and how these application teams can access those secrets based on the identity. HashiCorp Vault is for machine authorization and authentication, and we have a product called Boundary, which is for human access to the backend system, and the console is for machine-to-machine access. Now that we understand how HashiCorp Vault add value to the security posture in number of places, in this slide, I will go over what are the ways that HashiCorp will deliver the business value, right? There are, you can see here, a risk, speed, cost is where HashiCorp Vault adds a lot of business value. Let's talk about the risk. Inside the risk, there are two main aspects to it, right? Preventing credential exposure and eliminating secret sprawl. So let's talk about what is secret sprawl. Working with a lot of customers in last few years, I see companies tend to keep the secrets in many different places, right? I have seen customers putting the secrets in repositories, inside source code, hard-coded, right? Inside configuration management tools. So the secrets are spread across all over the place, and that itself introduced some challenges, right? One, visibility. There is no proper, tracking where those secrets are, right? And who is accessing those secrets. And the two is, in a scenario where there is a breach happen, how do you remediate it? Because there is no tracking where those secret lives. There is no way to go into that one specific system and rotate those credentials. So we are like, there is no a proper accountability, right? And the third challenge is not having proper auditability, right? So since they live across so many places, there is no proper auditing and who is accessing and and why and which secrets they're accessing. So in order to eliminate this secret sprawl, which eventually leads to credentials exposure, the solution here is using a centralized management solution like HashiCorp Vault, right? And two, having a standardization policy across the company that it's, if the application needs their secrets, it has to be, those secrets has to be onboarded to Vault. Having that standardized policy in place would eliminate some of this risk. And the two, the speed. Traditionally, we have seen when a application has to be released, it needs accounts to be provisioned to access to the backend database systems. And the way it works is the application teams open a ticket with security teams and database backend system teams, and it takes days or weeks to get those accounts provisioned, right? With today in this dynamic world, with using the HashiCorp Vault, it's dynamically can get you those service accounts provision when there is an agreement between the security teams and the application teams that if that specific application is onboarded to the HashiCorp Vault and there are predefined policies that the application is using the HashiCorp Vault solution, then there is no delays from the security team to approve that solution because it's already pre-approved, and those credentials get dynamically created on the database side. And when the application is done reading those data from backend systems, the Vault can revoke those credentials, right? So that will eventually lead speed a way to get the applications to the market faster. And also from the compliance point of view, the applications teams doesn't have to manage the rotation, right? There may be database credentials, certificates. The HashiCorp Vault will help to rotate those credentials dynamically without having to wait the security teams or backend database team to rotate those credentials. Also, Vault will help to expedite internal and external audit process. Since it's a centralized management solution, it keeps track of all the request, response, all in one place. It makes auditors' life easier to finish what involves in auditing, right? And as it comes to cost, it eliminates some of the time and work that is put into updating the firewall policies with adding static rules, right? So traditionally, since this all static VMs, when they had to access the Vault, it needs to have a certain firewall policies, right? It works well for static VMs, but right with the dynamic way of creating the workloads, running across multiple clouds, like running Kubernetes environments where the workloads are ephemeral, it's very hard to keep those firewall rules up to date. Since the HashiCorp Vault works based on the identity, it doesn't need to have those static policies, since all the authentication and authorization happens at the identity level. It definitely helps to reduce the time spent on the firewall policy updates and not have to manage those policies as new workloads come in, since it's all based on identity. And it also helps save developers a lot of time not to focus on how to secure the secrets. They don't have to focus their time on compliance requirements, right? So they can instead focus the time to make sure they get the right features to the market and let the platform teams or security teams manage that securing the secrets and compliance with using HashiCorp Vault. In here, I will go over some of the important aspects of using Vault that I went on one of the it before, how HashiCorp used identity-based security to automate access to secrets, data, and applications. And it also act as a security system of records that any application need read or write secrets. HashiCorp Vault is acts as a security system of record. And HashiCorp Vault also manage the life cycle of those secrets. If there are static secrets, if there are dynamic credentials, it takes care of rotating those credentials and revoking those credentials if that's a just-in-time access. There are a few editions that HashiCorp Vault provides today. Community edition, there's a Vault and Vault dedicated and self-managed. I'm going to play a video here real quick that's done by one of our HashiCorp employee clarifying what these versions are. Let me play that video real quick. You guys can hear this?
I can't hear it.
I can't hear anything. I don't think it's playing. I cannot hear it.
Still not here? Can hear it?
Yeah.
No.
Huh. I wonder, Jen, do you have any suggestions here? I'm playing this video in the PPT. I don't know why it's not giving audio out.
Is the video on YouTube? Usually if you stream it from YouTube, we can hear it.
It's not on the YouTube. This is uploaded into my into the PPT slides. I should have played it before. No worries. We'll get this sorted out and probably send this link later after this call. But overall, there are a few editions that HashiCorp provides. The community edition is open source. It's a BSL licensing where users can download the community edition and can try several use cases for developers especially. And then there is a HCP Vault, which is HashiCorp Cloud Platform, where it is managed by the HCP, the HashiCorp, all backend systems, the servers all managed by the HCP, and there is basically a secrets as a service, right? And there is a HCP Vault dedicated that which we're gonna use in our lab. And then there is a self-managed where our enterprise customers can get the binary and run within their environments, right? We'll be working with HCP Vault dedicated edition in our lab, which I'll go over next week on some of the benefits you're going to get from running HCP Vault dedicated. In this slide, I'll go over a high-level Vault architecture. There are 3 layers in the Vault, right? So it's the top layer is HTTPS API, which is the interface between the end clients and the Vault core. And then there is a middle layer, a barrier, and there is a storage backend layer, right? So when the Vault starts, it writes all the data to the storage backend, and any data going outside of the barrier is encrypted. So the storage backend itself is considered untrusted, and that's for good reason that if attacker get access to the storage backend, the data is still safe because it's all encrypted, right? So let me take a quick example of workflow here to explain what all these internal components are there for. So when a request comes in from end client to the HTTPS API, the Vault core is responsible to route that request to the specific auth method, since every request has to be authenticated. And based on what credentials the user has provided in the request, it gets routed to that specific auth method, and the Vault core validates the credentials, and in return, it gives back a token that's generated from token store. And along with the token, it attached the policy that's created from the policy store. The policy is basically it account for authorization, what end client can do, what secrets can be read from the Vault. So that token, along with the policy, is sent back to the end client. Any further request from the client will include the token, and if that request is going to read the secrets from the Vault, it gets routed to appropriate secret engine in the Vault, and the core will route to that engine and read the data, and in response, it will send that data back to the end client. When the user reads in sort of dynamic credentials, which has a TTL assigned to it, the expiration manager will make sure when the TTL is up, those dynamic credentials get revoked. The same applies to the token as well, right? So when the token that is pre-configured, if that has a 1 hour TTL, when that TTL is up, expiration manager will make sure it revokes that token. And there is a audit broker that makes sure it audits all the request and the response sent back to the client using audit devices. In a scenario where the Vault cannot audit that request, if audit device is unavailable, it will not process any request, right? That's a high level of Vault architecture. In here, I'll let Johnny to take over to talk about some of the internal components involved with the Vault, on authentication and secret agents.
All right, thank you, Kalam. So, authentication. When you are storing and keeping your secrets secure, of course, you want to store them somewhere secure, and part of that is using authentication to determine that you know who someone is when they log in, right? And then determine if they should have access to the secret that they're trying to get access to. So the first step of that is authentication. And Vault has many different ways to support authentication, and both for humans, for people, and for machines. A lot of compute secrets are for machine-to-machine authentication, and it's especially for web apps, you'll run into that as a very common need for HashiCorp Vault for the machine authentication. When you are setting up authentication methods in Vault, you're going to use a type of authentication that supports whatever your use case is the best. So for humans, you may use something like LDAP or Azure AD or GitHub authentication, so that when a person or a machine connects to Vault, it'll say, hey, this is my authentication path, and then Vault will verify with that authentication source, right? So to go back to GitHub or to go back to LDAP and say, hey, can you tell me the identity of this person? And once they've proven their identity, or the authentication trust has happened between Vault and the identity provider, that's when Vault will provide a token with a policy attached. By default, the token auth method is enabled in Vault. So when you first set up Vault, you can start giving out tokens immediately. And then other authentication backends you have to enable and configure before you can start using them. And when you have identities created and when you grant access via tokens, those have leases attached, which Kalam was talking about, TTLs, or time to live. It's essentially how long can we allow access for this identity into Vault. And there are various ways to renew those or refresh those to continue extending the TTLs. And go ahead on to the next slide, Kalam. So then the second part of identity and access management, right? So you have authentication and then you have access controls or authorization. What are they allowed to do? In Vault, we use policies, which, really simple, right? Who's allowed to do what? And it's a very declarative way to specify the path that is allowed to be accessed. So, which secret can be accessed, which path under a secret can be accessed. And then what are you allowed to do with that secret? Can you read it? Can you change it? Can you list every secret at a path, and so on? So there are a lot of different specific permissions that we can grant on a path in Vault. And then policies are denied by default. So if you have an empty policy, you will not have permission unless you start out with a root token, but a root token has built-in policies that allow them access to everything. All right, so then secrets engines are kind of where the secrets work happens, right? Where we store secrets and where we rotate secrets. And then also we have engines that will encrypt data. So it can take plain text data in and encrypt it, and then either pass the encrypted data back or pass a reference to the encrypted data back so that you can store your data more securely if you need to store it somewhere where it's encrypted. We have a bunch of different types of engines. So we have a basic key value store. We actually have two different types. I generally recommend using the one that supports versioning so that you can have different versions of a secret over time. Then we have dynamic credentials for basically everything you could want dynamic credentials for. Databases, for example, you can have credentials, a credential manager in Vault that will create and destroy database accounts for you on a regular basis, or on a push button command. And the advantage of that is to reduce the value of your database credential. So if you have a database credential protecting a very high value database, you don't want that credential to live very long, and you don't want it to be in very many places, or that credential is worth a lot of money to somebody who may want to take data out of your database. If you rotate that credential on a regular basis, it makes that credential worth less to an attacker and a lower risk to you, because you are making it not functional after a certain amount of time, whether that's hourly, daily, monthly. Anything is better than storing the same database credential for years on end. And then, as I mentioned, we have encryption as a service where you can pass data in and get back encrypted data or a reference to encrypted data. All of the secrets engines need to be enabled on all of the different varieties of platforms that we have. And there are built-in secrets engine plugins, and then you can also add custom plugins from the community or write your own secrets engine if you feel the need to do that. And Kalam, can you go to the next slide, please?
All right. Yeah, we'll discuss what are the best practices in this slide. So let's talk about the secret zero, right? So what is secret zero? So when I was going through the workflow before, when your end client authenticates to the wall, validate its credentials, it gets a token back, right? So that is considered a secret zero, right? So how do you make sure we are getting in a secure way that secret zero back to the end clients? So there are two ways to do that, right? You could provide static credentials. So in our case, in our next lab, we will be using a GitHub Actions to authenticate to the vault. So you could provide a PAT token, which is generated inside the GitHub, and configure a GitHub auth method on the vault so that the GitHub pipelines can authenticate to the vault using that static token. So the problem with having that long-lived static token is what if that gets compromised, right? So to avoid that, we'll be using dynamic credentials. We'll go over that in the lab. We will be using OIDC provider using .auth method on the vault side. What it means is the GitHub pipelines generate dynamic JOT token that is provided to the vault, and in return, it gives back a token that is only valid for whatever the TTL we configured the auth method with, right? So let's say, for example, take 15 minutes, right? If the pipelines runs for like a minute or two, we can go with 15 minutes TTL. And when that TTL is up, it's going to revoke those credentials or that token. And when the pipeline runs again, it gets a new dynamic token, right? So that's a approach to solve long-lived static credentials. Use dynamic secrets. In our lab, we will be storing a static secrets for backend systems in the vault. That is just for phase one. Probably if we're going to do like another session, we'll walk you through how the dynamic secrets will work. So instead of storing your database credentials as a static secrets in the vault, we'll be configuring database engines on the vault side, which will generate dynamic credentials when the GitHub pipeline needs to configure those credentials on the app side to retrieve data from database backend systems. What's going to happen is application will make a Vault API call to the specific database engine, and that will provision an account on the database side, and app will be able to retrieve the data it needs. And based on the TTL it was defined, it goes and revoke that account from the database. And again, if that app needs an account, it will keep calling the Vault API, generate dynamic credentials, and revoke when the work is done. Just-in-time credentials, which is more secure than using the static secrets. TTL, right? This is very important. By default, at the server level, at the Vault server level, the TTL is 32 days. We do not want to use the default, right? When we go configure the auth methods, we want to configure the TTLs that is applicable as per the application requirements, right? Based on how long that application needs, or we'll adjust the TTL accordingly. Since the tokens are considered storage, it has to manage storing the token and configure the replication. You had to replicate all those TTLs from your primary cluster to the DR cluster, which is add some load on the storage backend in the Vault, right? So we want to make sure we'll limit the TTL settings and not store those tokens for so long. Disable root tokens. So when you configure your Vault cluster, it gives you a root token, and that token has whole admin permissions. You can do anything with that root token. We want to make sure once you bootstrap your Vault cluster with the root token, you disable the root token, right? It should never be used for day 2 and day 3 operations. Monitoring. We want to make sure we have monitoring in place. As any other application you monitor, Vault requires to make sure you have monitoring in place for the reasons like how are your Vault request latency. Make sure your requests are getting processed within the set latency time, right? And also monitoring the tokens issued. How many tokens are getting generated? If you see any rogue application generating thousands of tokens, you want to make sure you're monitoring those, right? And also any privilege actions that are happening within the Vault, you want to have some sort of alerts tracking on those actions, right? This slide, I'll go over OIDC workflow, which will be working in our lab next week. I want to just put some high-level workflow to make sure we understand this when we go to the lab, right? So before we set up our pipelines to authenticate to the Vault, get the token, there's a step 1 that is to set up a mutual trust between GitHub OIDC provider and the Vault, and we set up roles, which is basically resources in the OIDC terminology. So once we have set up that trust and pre-configured that GitHub, the JOT auth method, now the GitHub pipelines are ready to make a request to the Vault. So the way it works is GitHub Actions will generate a JOT token by making an API call to the GitHub OIDC provider and send that token, that JOT, to Vault. So the Vault can verify that JOT token is valid by calling back to the GitHub OIDC provider. And once Vault validates that is a valid JOT token, like say for example, if you are providing the JOT token is nothing but like when you provide a username password to any website, right? So it's similar to that, right? But it's a different stored in different way. that jar token, once the vault validates it, it gives back the token to the GitHub pipeline, right? And any further request to the vault to read the secrets, GitHub pipeline will send that token along with the request to read the data from the vault. So once the pipeline completes, based on the TTL, that token will get revoked, and any further GitHub actions, and if any further runs, it will follow the similar process to dynamically generate the token and read the secrets from the vault, right? That's the secret zero I was talking before, where the best practice is using dynamic credentials, but not the static token. With that, yeah, I'd like to open up if any questions the team has.
Thank you very much. That was awesome. If anyone has any questions, feel free to unmute yourself, or you can ask them in the side chat, and we will address those.
Yeah, sure. So the JOT is a JSON web token, right? It's based on the OIDC authentication method. That explaining the OIDC can itself take hours to go over it. But the JSON web token is something that is actually dynamically generated by calling a OIDC provider, and that token is provided back to the vault to validate if that is a right token, the right JOT that was generated from the OIDC provider, right? So what I will do is probably in our next lab, I will set up quick 5-10 minutes to go deep into that JOT and how the OIDC overall works.
Super, thanks.
Great question, Gloria. Thank you.
Can I ask too, like when you're using the vault, I'm guessing it has a whole bunch of like key values and pairs. Like, how do you kind of, if you could just kind of briefly mention, like, how do you include it in like your code? Does it authenticate? I'm still, I guess, a little fuzzy on how you actually end up using it like in your code. Is it, yeah, maybe if you could just do an overview summary.
Right. So the Vault provides a nice API interface, right? So yes, you're right. You had to store the secrets in the key value pairs. You know, if you're talking about the static secrets, they will be stored inside the Vault in a key value format. And then within your application, you can make a API call. There are several libraries based on your application, right? If you have a .NET application, if you have a Python application, there are several libraries provided by the HashiCorp, and there are also community libraries that you can use within your application to make that API call. Is that answer your question? Or we can show a quick example, you know, how to make those API calls from within your application in our lab.
Oh, okay, great.
Yeah, and then Gloria, to kind of elaborate. So like for our exercise next week, we're going to be working with Kalam to set up our own secrets within our workflow. So we have different GitHub actions that use static secrets that are either environmental variables or secrets that we have saved in the GitHub repository. And a part of the exercise is replacing those static secrets with the secrets that we're going to be creating in the vault. And the way we retrieve those is by editing the current workflow files specifically. So instead of specifying, on a certain line that we're going to be using this specific secret that's saved as a static variable in the repo, we're going to add a few extra lines to say, I want you to log into our to the secret vault or the vault that we created, retrieve these secrets, use this token to authenticate with, and then we'll add a few other lines to use the secrets within the workflows themselves. So it calls the API, makes the connection from the GitHub workflow, authenticates, retrieves those secrets, and then later in the workflow file, we'll define how, we'll specify to use the secrets that were retrieved. So we kind of break it into like two sections. We will retrieve the secrets, and then we will use the secrets as like we would if they were just static.
Oh,
I
okay,
see this
thank
good question. I see this question from about if the vault can detect if there is a exposed authentication token. Are you referring to that token that is generated by the vault given back to the end client? I think it's oh, I see Johnny already responded to that. Cool.
That is a very cool feature though, because it's so
Yeah.
is that still in beta? Is that how many of your customers are a part of that beta? Do you know if it's becoming more mainstream just to monitor those things?
Yeah, it is definitely a well asked feature request on detecting those. And right now, yeah, it's still in the beta, but I'm not sure how many of them customers are enrolled in it. But that's definitely a lot of our customers are asked for and looking forward to use that feature. I was just coming out of a and that was shown in action today. It's amazing how it detects that secrets. Maybe if I get an opportunity next week, if you have time, I'll show that in action how the Vault Radar works.
Thank you.
Is the benefit of HashiCorp's Vault, like what are some of the differences? Because I think Microsoft has a Key Vault also. Are those specific to only to their products?
Yeah.
Okay.
Yeah, great question. Great question. This is a great question. Yeah. The way HashiCorp shines in that space is we are cloud agnostic. Let's say you have workloads in AWS or Azure, right? So having HashiCorp Vault will able to read the secrets from any cloud provider, and the two, where HashiCorp Vault differentiates with the cloud provider's vault is using dynamic credentials, right? With the HashiCorp Vault, you can get just in-time credentials. That is what makes a lot of differentiation between, like you said, Azure Key Vault or AWS Secret Manager, and since it's a cloud agnostic and it can be accessed from anywhere, and having a centralized logging, so we're not keeping the secrets. Because if you see, currently every enterprise wants to run the multi-cloud, and running the secrets in its own native cloud provider will not have proper centralized logging. If you have a centralized solution like Vault, there is a proper logging, and we can see who accessed when, and if in a reason those credentials get exposed, there is a remediation plan. You can apply it in one place to revoke those credentials instead of going through a few different places to fix that issue.
Well, I know we're running a little over time. I do excuse the please excuse the delay on my end. But I just wanted to thank you, everyone from HashiCorp, Kalam, John. I appreciate that very much. Um, does anyone have any other questions about this? Next week, we will be diving in to the vault ourselves by creating secrets and then updating the workflow. So you'll have hands-on experience actually using this technology. So that'll be next Wednesday during our pair hour. Kalam will be joining us with that as well. So if you have any other questions, please post them in the chat. But if not, again, thank you so much from everyone from HashiCorp for being a part of this and putting in the time and effort just to create this and inform everyone. I do appreciate that. Yeah, so if you don't have anything else, we'll go ahead and wrap this up and have a great day.
All right, thanks everyone. Thanks, Ethan, for setting this up.
Yeah, no problem. Thank you so much.